In a liquid-liquid extraction using a separatory funnel, you first place the funnel in a ring stand, and then underneath the funnel you place a beaker. This beaker serves as a catch basin in the event that you leave the stopcock open. When ready to do the extraction, close the stopcock and then pour in the solution to be extracted. In this particular case, it's an aqueous solution. So carefully add the solution. And then rinse the flask with additional solvent to remove any excess solute. Swirl, and then pour that into the SEP funnel. At this point, then you add the solvent that you're using to extract the original solution, and typically use about 2/3 the volume of the solution that you're extracting. The less dense solution will float upon the more dense solution, and you will be able to see a sharp boundary between the two liquids, even though they both may be colorless and clear. Simply place the stopper into the separatory funnel, remove the SEP funnel, and invert. Immediately vent the SEP funnel to release any gas pressure that may build up due to evaporation of low boiling solvent or a reaction that may liberate a gas such as carbon dioxide. To mix the layers, gently swirl, and do this for about 10 seconds, and then vent the SEP funnel once again. Repeat this process for a total of about 1 minute, swirling for 10 to 15 seconds, and venting to release any buildup of pressure. After 1 minute and venting, return the SEP funnel to the ring and remove the stopper. Allow the SEP funnel to stand for about a minute in order to allow the two layers to separate. And you will see a definitive boundary shortly form. Replace the beaker with an Erlenmeyer flask that will serve to catch the extracted solution. Very often you may not know which layer is which. You can test this by adding a solvent to one of the two layers. In this particular case, I know one of those solutions is in fact aqueous, so I will test it using a drop of water. If the bottom solution is water, the drop will travel through the upper liquid, and then you'll see it strike the bottom. If the upper liquid is the water, then the droplet will not travel through. And so just a couple of drops, and you should be able to see it actually travel through and then strike the bottom solution. So the bottom solution in this particular case is the aqueous solution. Once they have separated, open the stopcock and collect the bottom liquid in the Erlenmeyer flask. As it approaches the bottom, you may wish to slow this down so that you do not pull off the top layer. It's near the bottom, near the neck, and so at this point I simply turn it a few times until I pull the bottom layer off. And so now I have the bottom layer securely in the Erlenmeyer flask. The top layer, in fact, is removed by pouring it through the top of the separatory funnel. Remove the separatory funnel and simply decant the liquid into the flask. And so we've now separated the two solutions. If you need to repeat the process, place the solution back into the separatory funnel and repeat. In this particular case, I'm happy with the first extraction. And so now I have my solute in the separatory funnel, but I now need to dry this organic layer. It is wet with the water. This can be accomplished using anhydrous sodium sulfate. Simply put a few granules of the anhydrous sodium sulfate into the flask and then swirl. And you do this about a minute and repeat the process until you see free granules floating. At this point, all the granules are still stuck to the bottom of the flask. So just add a few more. And then swirl. And there are a few granules floating free in the bottom. And so that means that the liquid is sufficiently dry. And allow that liquid then to stand for 1 minute. At this point, we need to liberate our solute from the liquid. So we decant this into a round bottom flask, carefully leaving the drying agent behind. We need to further rinse the drying agent to remove any solute that may be trapped. So we use some fresh solvent, in this particular case, a little ethyl ether. Again, swirl and decant. And now the solvent is ready to be evaporated.